Okay, we're back. So basically, 7B, don't worry about it. I'll put this on bright space. So I'll say, ignore 7B, don't worry about it. So on problem on your test, you only need to worry about, make sure you know how to do 7A, the first part of that. All right, so let's move on to number 8. Okay, so assume the industry for hot wings in Douglasville, Georgia is perfectly competitive. There's 60 restaurants that serve hot wings. 35 restaurants are high cost. And you can describe their supply by 2P. All right, and there's also the remaining low-cost restaurants, and there's 25 of those. And you can describe their supply curve as 4P. So as you can see, whatever the price is, these low cost, because they have lower costs, more profitable, they're going to produce more. They're going to supply more hot wings. All right. So what we want to do is we want to derive the short run industry supply curve for hot wings. First thing. So to get the supply curve for the whole market here, we just add all these up. 35 high cost plus 25 low cost. And what is that? 35 times 2P plus 25 times 4P. That's going to give you 70P plus 100P. So the market supply is defined by 170P. All right. For each increase in dollar, the industry here is going to produce 170 more hot wings. All right. So we want to find the market equilibrium price of quantity. So we need to set this equal to market demand. And so our supply is 170P. Our market demand is 1,600 minus 135. Minus 135P. All right. So if we add 135P to both sides, we get 305P equals 1,600. And so if we divide by 305 on both sides, 1,600 divided by 305 is 5.25. Okay, so we got our equilibrium price. So what's the quantity? We can use either the supply or the demand. We'll use the supply curve because it's a little bit simpler. Just 170 times the price, 525. And so the equilibrium price is going to be 872. All right. So our equilibrium price is 525. At this price, and we have 872 orders of hot wings that are produced each period. All right, so those are our two equilibrium quantities. Now, okay, if this equilibrium price, remember these restaurants, they take this price as a given. They can coordinate the behavior and like collude or whatever, but they can't. There's too many of them. It's not possible to do that. So they each individually have to just take this price as a given. All right, so what will they each produce at this given price of 525? Let's do that next. It's a B. How many are produced for each one? So let's look at low cost first. And we said their supply can be defined by 4 times P. And our P we said was 525. So each one of these will produce 21 orders of hot wings. What about our high cost? What will they each produce? I don't know why I put that. Well, they don't produce quite as much. I mean, they have a higher cost, marginal cost, like at any given price, and like therefore they're less profitable. They're not going to produce as much. 2 times 525, they each produce 10.5. 10 one day, 11 the next. Okay, so we have this. We have their each prospective type of restaurants. What they would produce each day. Well, let's see what happens here. What if what if average total cost is $5? What's going to happen here? All right. So let's first describe what's happened. Then we're going to do a diagram, kind of illustrate, what goes on. Remember, in the long run, if the price is greater than average total cost, firms enter market. They recognize this profit-making opportunity. They see there's positive economic profits. So given what they have other opportunities to do other things, but this one here, this is a better deal. They're going to actually get positive economic profits. And if that's the case, they'll enter this market here. And it's going to be the case when you have this going on, because some firms, well, maybe I don't make as much in this, what I'm doing now, or I have a choice between two. Well, they see this, and some of them are going to enter this market here. But what if the price is less than average total cost? Well, in the long run, firms exit. In the short run, they still the price may be greater than average variable cost, so they may stay in. But in the long run, when they can adjust everything, there's going to be some firms that exit, right? And so what do we have in this case? Remember we said our price was $5.25. Well, this is greater than the average total cost of $5. So firms are going to enter. Right? So now let's draw a diagram what happens here. Illustrate what happens. And what we'll do is on one side, we're going to draw our market. Wing market. We'll also look at a low cost firm. Low cost restaurant. Okay. Remember, the market determines the price. All these individual restaurants together make up supply and then demand of the consumers here. And we said that price that came out of this, that brings us in equilibrium, is $5.25. And that quantity we said was $8.72. For this restaurant, it takes this price as a given. It just has to accept it. Doesn't matter what it produces, this price will stay the same. So this is the demand curve. It's also the marginal revenue. For each unit, that's what they're going to get. This is the price they get. No matter how many they produce, they get the same $5.25. Where do they maximize profits? Well, that's where they got marginal cost comes into play. Remember here with marginal cost, if marginal cost is greater than marginal revenue, well, they're losing money on that last unit, these last units of production here. It's costing them more to produce it than other revenue they're generating for these last units. So they need to decrease the production. If marginal cost is less, like it is here, marginal revenue, well, they still have extra profit they can make, so they want to increase production. Where they max profits is when marginal cost equals marginal revenue. And remember, we said marginal revenue equals price here. Okay, so it's where the price equals marginal cost. And we said for these low cost restaurants, they would produce 21 a day. Okay. All right. Now, lastly, we need to bring in our average total cost. So let's draw this something like this. And we said where they produce at 21, the average total cost is $5. Okay. Well, this is positive economic profit. They're getting 25 cents more per order of wing than what it costs here. So profits are positive here. Okay. And because of that, firms are going to enter. And firms enter the market, increases supply. The supply curve is going to shift. And they're going to keep entering this market until they push the price down enough where the price level equals the average total cost. So what would happen here in this case? Maybe you see a reduction in production from this low cost restaurant. But overall, what's going to happen? Let's just assume this is the new demand curve. Things going to shift down, and in total, there's going to be an increase in wings produced in the market here because of this excess average profit here that we have. Firms are going to enter, increase the supply, and bring this down where the price level equals average total cost in the long run. Because there's zero economic profits in the long run for perfectly competitive market. All right, so we have D here. Let's say a study comes out showing that eating hot wings increases your chance of getting cancer. What happens to the price? Well, let's erase this. Just draw this out real quick. It doesn't say you have to draw it out, but I'll just do this to illustrate it. Well, demand is going to decrease because it shows wings increase your chance of getting cancer. But decreases the price, right? Less people are buying wings. If they keep the price at $5.25, well, these restaurants won't be selling all the wings they make. So they need to decrease the price to bring this in equilibrium. That way they don't, have wings go to waste here. And when they do this, it drops the price down. Now, what happens? Well, if this dropped to $4.75, this would be below the average total cost. Firms exit if price drops below average total cost. Okay. And so what happens because of that? This pushes the price back up. Okay. Firms exiting increases price. But what's going to happen in the long run, wherever this average total cost is at, it's going to end up where price is equal to average total cost. Okay. Demand's not going to change this. What happens? Demand changes can adjust the price in the short run, but since firms can freely enter and exit in the long run, it's going to always trend toward the price level equals average total cost. Okay. All right. So that's it for this problem. Let's go to number 9. Let's go to number 9 here. Tesla has market power in producing electric cars. The firm faces a demand curve of Q equals 120 minus 0.5 P. Q is measured in thousands of basketball. I got the wrong, so it should be cars, and it's P is thousands of dollars per car. Tesla has a marginal cost curve that is equal to MC equals 2Q. All right. First thing we need to do, we need to find the inverse demand, because we want to find, what's the profit level maximizing price of output. We find the output first, and then from that we can determine the price. But we need to find inverse demand first. So you take your regular demand here, Q equals 120 minus 0.5 P, and you get the inverse of this. So you add 0.5 P to both sides, 120 minus Q. Then you multiply both sides by 2. This gives you P equals 240 minus 2Q. So that's the inverse demand. Now we need to get the marginal revenue. Now I know we have that formula and everything. Basically all you need to do here is just marginal revenue. It's going to start at 240. It's going to be, when quantity is equal to 0. It's going to start at the same point, but the difference with marginal revenue, it drops twice as fast. The slope's twice as steep. So essentially just 4Q here. All right. And so that's your marginal. Oh, why did I write P there? That's your marginal revenue. You're just taking the slope is twice as steep, and so you get 4 here. All right, so let's find everything. So we set marginal revenue equals marginal cost. You know, this is the same thing with all firms. When they maximize their profit, they do this when marginal revenue equals marginal cost. The difference here is the price doesn't equal to marginal revenue and marginal cost. Now, price is different. As you can see, marginal revenue here, price here, they're two different things. Let's see here. So marginal revenue we said was 240 minus 4Q. Marginal cost we said was 2Q. So if we add 4Q to both sides, we get 240 equals 6Q. Divide both sides by 6, we get Q equals 60. That's our profit maximizing quantity. What about on the price? Well, the price, 240 minus 2 times the quantity we got here, 6. So the price is going to be 120. Looks like I did that wrong. Oh, it's 80. Sorry, that's 40. This should be 40. That's what I did wrong. Maybe something didn't match up. Sorry about that. That's 40. And so that's going to give you 160. All right. Equilibrium price of 160, quantity of 40. Now let's draw out what's going on here graphically with a diagram so you can see what's going on. And then we'll come back to that. 2 for calculating our deadweight loss. So here's our price. Here's our quantity. Here's demand. And remember, marginal revenue drops twice as fast. Right, so the slope's twice as steep here. Marginal cost, we said was 2Q. And you maximize profits where marginal revenue equals marginal cost. And our quantity we got there was actually 40. Did I do that wrong? I got that wrong on the sheet. Yeah, I need to switch that. Okay. And so the marginal revenue here is going to be 80, but there's a markup. You're not charged with what marginal revenue, marginal cost is. You actually have a markup above marginal cost. Markup of $80. That's from this market power. And as you can control, you have an impact on the price level when you're doing this. Like you're increasing production lowers your price, decreasing it will raise it. All right. And so this is our price is being charged. This is the markup they get, and this is the equilibrium quantity that we solve for. Now, what's the issue with this? Well, the issue with this is you're not getting complete efficiency here. All right, the efficient, perfect competition outcome, when you have the most efficient outcome here, is going to be when marginal cost equals the price level. All right. And so because of that, we have some deadweight loss. That's what this next part wants to do. It wants to find the deadweight loss. And so essentially what the deadweight loss here is going to be this little triangle right here. All right. So we want to find this quantity here. All right, so we're going to set the marginal cost, which is 2Q. We'll set it equal to the price, which we said was 240 minus 2Q. Okay. 240 equals 4Q. Q equals 60. All right, so that's going to be 60 right there. All right. Now to find the deadweight loss, we just use our triangle formula: 1/2 times base times height. So 1/2 times the base, 60 minus 40. Height, 160 minus 80. All right, so this is going to be 1/2 times 20 times 80. So 1/2 times 20 is 10. So it's essentially going to be $800. This is our deadweight loss here. This is what's represented here in this little section right there. All right. Deadweight loss. $800. Okay, what is the next part? So that's C2 right here, this diagram. We're showing all that. Okay, yeah, we want to show what happens if the marginal cost decreases. I do something that lowers our marginal cost here. And we want to see what happens if marginal cost is equal to Q. And this shows that, you know, that firms and monopoly, even then, they still have an incentive to like lower costs. This is what this is going to show. So we're going to look at where marginal cost is equal to Q. So we set marginal revenue equal to our new marginal cost. And so that's 240. $240 minus 4Q equals Q. So 240 equals 5Q, and the quantity is equal to 48. So what's this price? 240 minus 2 times 48. 144. That's the new price. So let's draw this. All right, as you see, we have a higher quantity that maximizes profit, and we have a lower price. So this is moving it towards a more efficient outcome. Like this is more efficient than the original one. There's more surplus now as a result of this. All right, so let's draw this out. Quantity. Here's our demand. Here's our marginal revenue. Let's say this is our original marginal cost, and this is our second one. Remember, we saw that was 40. This is 80. That's 160. That's our original outcome right here. But then do the marginal cost dropping? Well, what happens? This intersection with marginal revenue equals marginal cost is lower. But more importantly, there's an increase in production. Well, what about the price? Well, the price is lower as well too. So you can see there's a larger surplus now. Okay, due to this increase in productivity here. Something that's lower than marginal cost. The surplus went from right here. Right, to all the way increased to right here. There's a big increase in total surplus. It's always a win whenever firms can produce something more efficiently. Okay. All right. Anything else? No, that's okay. So that's it for a monopoly. Now let's look at a game here. Number 10. You know, with game theory, you know, it's about when you have a competitor, you're paying attention to what they do, and it influences your decision here. We're going to look at a case where it's two radio stations competing against each other. And so let's draw out this game. It's 99X. They're going to be the row player. The column player is going to be 97 the river. They're competing in the Atlanta metro area, and they have 3 different types of music they play: country, pop, rock. Country, pop, rock for both of them. And so here's the payout. And so when you're looking at these payoff matrices, let's say if they both play country here. Well, 9X gets 2, river 4. So the row player here, his payout's always his first term. The second term is always the con player. Okay, let's fill these in, and then we'll answer problems. Are there any dominated strategies for either term? So what we'll do, we'll just go through it. We'll mark out what their move is first before we determine if there's anything here. All right, so let's go 9X first, their moves. So what they choose is going to depend on what 97 the river does. So if 97 river chooses to play country, their payout's going to be either 2, 4, or 5. So they're going to choose rock. Get a payout of 5, that's higher. What about the river chooses to play pop? Well, rock is the highest payout for 9X here. 8 is better than 4 or 5. What about the river plays rock? They have a choice between 4, 2, and 3. Well, they're going to play country in that case. They won't play rock. So is there a dominated strategy for 9X? Yeah, they would never play pop. Okay. What about the river here? Let's look at them compared to 9X. So they're always going to make their choice based off the move, 9X. If 9X has country, their best payout. They either play country 4, pop 1, or rock 5. Well, they're going to choose to play rock. What about if 9X plays pop? What's 97 river's best move here? Well, it's to play country. Payout of 7 is better than 5 or 6. What about if 9X plays rock? What's their best move? Do you play country to get 5, pop to get 6, or rock to get 3? Well, it's 6. They're going to play pop. So just depend. They can, depending on what 9X does, the river could play each move. They could play country, pop, or rock could be their best move. So they have there is no dominated strategy. What about dominant strategy? Is there a move that they would? So the dominated strategy is when they would never make that move, regardless of what their opponent does. So 9X here would never play pop. They would never choose to do that. What about a dominant strategy? A strategy they'd always play regardless of what their opponent does. Well, they all will play different, types of music depending on what they do. So there is no dominant strategy here. Yeah. All right. So what about the Nash equilibrium? This is where both, if you do this like either underline or check, it's where they both could potentially do this. And here you don't have a pure strategy. You have 2 Nash equilibria. One is 99X plays country, and 97 the river plays rock. The other one, 9X plays rock, and 97 the river plays pop. Those are your 2 Nash equilibria. Now I'm going to make another video. I just noticed I need to make some adjustments to question number 11. I did it wrong, so I need to solve that first. And then when I'll make this. There'll be another video for that. And on with that, I'm going to make an extension to this. That is, I'm going to play this where it's not a simultaneous game like this, where the moves are done at the same time, but it's sequential. And we're going to have 99X be the first mover, and we're going to see if they get a first mover advantage. That is, they can move themselves to a better equilibrium here. Now there's 2 possible ones here. So they're going to do some kind of mixed strategy. And, that what would be best, though, if they could get this equilibrium, to get this 8 instead of the 4. So we'll see if that's possible with this when it's a sequential game. Okay. All right. So I'll come back, make another video for number 11 and also that. Let's see here.